Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about basics of bit manipulation. The prerequisite for this video are you have to know what is meant by binary number and you have to know some basic operations of bitwise operators. If you don't know about that, I will give you a link in my description. Go and watch those two videos and come back to this video, right? Okay, first one is how to extract the LSB bit. What is meant by LSB bit? Take for example, take a 51, take 51, right? The binary equivalent is 110011, right? We want to take this bit, it is a least significant bit, right? So how to take this? I can normally divide by 2 and take the remainder, that is 51 mod 2, which is equal to 1, right? It's equal to 1. Okay, I can simply do that stuff. Or else by using bit manipulation, I can say 51 and 1, which is equal to 1, right? 51 and 1 is equal to 1. But how? Let us take 110011, and what is the binary equivalent for 1? It is 000001, right? Now doing and, carefully see here, these two are same, so I will put 1. Other than that, there are all zeros, right? All zeros. So 00000, right? So this is the value. So what is the value? It is 1. Fine. So set bit is 1. If take for example, it is 50. What is the binary equivalent of 50? 110010. Fine. Now take 1 and do AND operation, right? By doing this AND operation, we will get, right, 000000. So this is equivalent to 0. Fine. So this is the method to find what is the LSB, least significant bit. Okay, what is the use of finding this least significant bit? So I can say least significant bit is equal to n mod 2. That is it's equal to n and 1. So what is the purpose of this n mod 2? That is, in which case we will do some stuff like modular division with 2. I can say during checking whether the number is even or odd. During we are checking the number is even or odd, we use this n divided by 2. Sorry, n mod 2, right? So same, I can use n and 1. If n and 1 is equal to 0 or n and 1 is equal to 1, what are the result? When it is equal to 0, it is even number. When it is equal to 1, it is odd number, right? Fine. So this is my observation. So let us see the code. See here, num is equal to 51, and I am printing num mod 2 and num and 1. It returns 1, right? If I take this and put 50, my bit is like this. So now my LSB is 0, right? Now nums2 is equal to 2, nums2 is equal to 7, nums3 is equal to 10. Print nums1 and 1, nums2 and 1, nums3 and 1. The LSB bit are 0, 1 and 0, right? Now I can prove you that nums1 and 1 gives me 0, so it is an even number. Nums2 and 1 is 1, so it is an odd number. Nums3 and 1 is 0, again it is an even number, right? So that's what I have told you, how to classify even or odd by using the bit manipulation, right? Fine. Now we have seen that how to take the LSB bit. Now we are going to see how to check whether the ith bit is a set bit or not. Usually set bit means a bit which contains 1, okay? So the ith bit is set bit or not. Just see here, if I give I is equal to 4, I want to check whether 0, 1, 2, 3, 4, this bit is 1 or 0, right? The highlighted bit is 1 or 0. How to do this? Okay, we can do this in two ways. I will take that example. 50 binary equals 110010, right? Now my I value is 4, so I want to extract this bit and I want to give the output as 1. So how to do this? How to do this? Just assume if this is my another number, this is my another number, and I do AND operation. I'll get my output as this, which is equivalent to 16, which is equivalent to this 16. So I can say this bit is set bit, this bit is set bit, right? This is the one approach. This is the one approach. Now what is the second approach? I can say 1 1 0 0 1 0. I can move this bit 4 times. I can move this bit 4 times. So that 1 time I have moved, 2 time, 3 time, 4 time. I have moved 4 time, and I am checking the least significant bit, whether this bit is set bit or not. Yes, it is set bit, right? So this is the second approach. Right? So these are two approaches. Now how to do this? Let us take the first approach. How to do the first approach? See here. I want this one at my fourth position. So I can move 4 steps in left. So 1 left shift 4. So that 1 will be shifted 1 time. 1 will be shifted 2 time. 1 will be shifted 3 time. 1 will be shifted 4 time. Right? And when I am shifting 1 to 4, I have to check and whether doing with n is not equal to 0. If the satisfied condition, it is set bit, because it gives the value of 16, right? So it is not equal to 0. I can say it is a set bit. Else I can say it is a 0. It is not a set bit. Right? So this is the first approach. Now, how to do the second approach? I can do second approach by, I want to shift n 4 times in what? Right side. So shift 4 times in right side and 1. Now doing this, if the result is 1, it is a set bit. If result is 0, it is not a set bit. Right? So these are two approaches. Now how to implement these two approaches? Just see here. There's a code. I is equal to 4. Nums and 1 left shift I, so that it will be at the 1 will be at the ith bit. Okay. Now while doing this, and if I get non-zero value, it is a set bit, right? And this is the code where we use the second approach, like moving the number 4 steps to the right side and checking whether the LSB bit is a set bit or not, right? So these are the two approaches. Setting the ith bit. Till now, how to find whether ith bit is a set bit or not? Now in this block, we are going to see whether the ith bit is a set bit or not. Although in two conditions we want to set the bit. Okay. For setting the bit, we use OR operator. Why we use OR operator? Just assume the bit is 1. Using this OR operator, my answer will be 1. If the set is 0, using this OR operator is 1, will give 1. So whatever my bit, OR with 1, OR operator with 1 will give me the result as set bit. So I can use this R1 to make the ith bit as a set bit, right? So how to do this? Okay, fine. Let us take a number. So here 10 and I is equal to 2. Fine. Let us take the number 10. So its binary equivalent is 1 0 1 0 and I is equal to 2. So I want to set this bit. How to set this bit? Now I can know if I do a OR operation with this number. OR operation with this number, I get 0 1 1 1, right? Which is equivalent to part number 12 or 13. This is 1, right? So 2 power 0, 2 power 1, 2 power 2, 2 power 3, 8. We can get this number 14. So the number is 14. We can get this number, right? So I set this bit. Fine. So this is the approach. Now how to make this number? As in previous code, we have seen that 1 left shift I, 1 left shift I. So while doing 1 left shift 2, first time while doing for one time it will be 1 0, and for doing for second time it will be 1 0 0. Right? I got it. I got the number. I got a number. Fine. So this is the procedure, and I want to do a OR operation with A. That's all. That's all right. So that's what the code represent. This code represent that same thing. Right? Answer is 14. Fine. Now deleting the ith bit. Deleting the ith bit. For deletion, we use AND operation. AND operation. Why? Because let us take the same example. What? 15 and 2. 15 and I is equal to 2. What is the binary equivalent of 15? It is 1 1 1 1. And what is second bit? What is second bit? It is this one. This one is the second bit, right? 0 1 2 3. So this is the second bit. Now I have to give the result as my output should be like 1 0 1 1, which is equivalent to 11, right? I want to do this. How to do this? How to do this? So see here, this is my number. This is my number. I want to do an AND operation with 1 0 1 1. So doing this AND, I can make the result as like this. When we are doing 1 and 0 and with 0, what will my output? 0, right? That's what the simple thing I have wrote here. So how to arrive this number? Fine. I can make 0 1 0 0 and invert it by using NOT operator. I will get 1 0 1 1, right? So how to get this value? We have seen in previous code, right? 1 left shift I will give what? This number. Doing a NOT, I will get 1 0 1 1, right? While doing this 1 0 1 1 and with this number, I will get the result as 1 0 1 1, which is equal to 11, right? So this is the approach. Let us see the code. See here, I want to I store the deletion value in the delete variable, right? Now I am just doing num and delete. That's all. Finished, right? So this is the simple thing. This is a simple operation. Now we are going to a concept wise problem. See here, how to make sure we are doing a power of 2. How to make sure a number is a power of 2. Let us take for example 2 is a power of 2. It's a power of 2. True. 4 is a power of 2. 5 is not a power of 2. 6 is also not a power of 2. 8 is a power of 2. So telling about a power of 2, the number which represent by the power of 2 or the power of 2 numbers, like 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. So 1, 2, 4, 8, 16, 32 goes on. These are the power of 2. Now, how to find whether a number is a power of 2 or not? Let us think in a different way. Just see here, I have given some observation, like I have wrote up to 16, and see what are the numbers that are power of 2. See here, this 1, this 2, again this 4, this 8 and 16. But carefully observe that. First let us take this 16. Carefully observe these two numbers. Wherever we have 0 in 16, there we have 1 in 15. Wherever we have 0 in 15, we have 1 in 16. Okay, it's for 16 case. Okay, fine. Now take this 2 number. It is also like wherever there is 0, like take this alone. This last 4 digits alone. Wherever we have 1 in 7, we have 0 in 8, and wherever we have 1 in 8, we have 0 in 7. Right? So I can say that whenever there is a 0 in power of 2, there will be 1 in the power of 2 minus 1. Power of 2 minus 1. So I can say, if I do AND operation between, I can do AND operation between power of 2 and power of 2 minus 1, I will definitely get a 0. Fine, fine. Let's take for example, if I have 16, what is the binary equivalent of 16? 1 0 0 0 0. What is the binary equivalent of 15? 0 1 1 1 1. Doing AND operation, the result will be 0 0 0 0 0, which is equivalent to 0. So I can say if n and n minus 1 is equal to 0, then I can say it is a power of 2. It's a power of 2, right? Right. So this is the observation I have got. Fine. Let us make this as a code. See here, I have declared some array, and for element in array, if element and element minus 1 is equal to 0, then print the element, because they are the power of 2, right? So the power of 2 are 1, 4, 8, 32, which are present in this array. Fine. So this is the approach we want to do when we have asked for a number which is a power of 2 or not. Now we can see the another concept. In this concept, clearing the LSB up to ith bit. I is equal to 4, A is equal to 59. So let me write this. 59. What is the equivalent of 59? 1 1 1 1 0 0 1 1, right? 1 1 1 0 1 1, right? Now if they have given I is equal to 4, I want to clear this last 4 bit. I want to clear this last 4 bit value and make them as 0, right? So let me take this example. What number I have to write here so that I can clear all the 4 bits at the end. I can take this number so that my all 4 bits at last will be cleared, right? This is the step 1. This is step 1, right? Now, how to arrive this number? How to arrive this number? So the step 2 is, I can say 0 0 1 1 1 1. If I make this number, this binary number, and make I invert in each and every bit, I can make this number. Right? So how to make this number? Step 3. How to make this number? The decimal equivalent of this number is 15, right? So I can say 16 minus 1 is equal to 15. 16 minus 1 is equal to 15. Fine. What is the binary representation of 16? It is 1 0 0 0 0. Right? This is my third step. And then coming to the fourth step. How to make this number? Just assume I have I is equal to 4 and I left shift 4. What will be the answer? It is like, when I am left shifting 1 time, it will be 1 0, and when I am left shifting 2 times, it will be 1 0 0, next 1 0 0 0, and at next I will be getting 1 0 0 0 0, right? So this is my required answer in step 3. Now I have got it. So I can make these steps in reverse. Come along with me. Like, first of all, I wrote 1 left shift 4, right? This step, and I have to do a minus 1 for the result. So minus 1. I can better replace this 4 as I, because in question they have given I, right? So I. Now going to this second step, I have done a not operator to the 15, to this 15. So I have 15 in the second step, that is this one. Now I have to do a not operator to this. Fine. Now finally, what is the first step? Do AND operation with this number which is I derived here, right? So do an AND operation with n. So this is the pattern, or this is the formula I have derived from step by step to make ith last bits as 0. Fine. So what is my expression? It is not 1 left shift I minus 1 and n, right? So this is my output. Fine. So this is my formula, and let us see in code. See here. Here is my formula, right? Here is my formula. I 1 is left shifted I times, then minus 1 is done. Then I am doing not operator for whole thing. Then I am just doing AND operator with A and the result, right? This is what, when we want to clear the bits up to LSB from ith bit. Fine. Now let us take a reverse. Like, I want to clear MSB up to 8 bit. I want to clear MSB up to 8 bit. Let's take for example 59 111 0 11, right? So if I give I is equal to 3, what is the third bit? This one is the third bit. I want to clear all this bit. So what is the result? 0 0 0 0 1 1. This is equal to 3. So this is my second question. This is my second logic. Now let us take the same approach. Always take the binary representation. Now what should be my number that should be done with any operation to this number to get the result? I can say 0 0 0 1 1 1 and doing AND. Fine. 1 1 0 0 0 0. This is my result, right? So this is the number I require to do a stuff with AND so that I get the result, right? So how to get this number? We have already seen in the previous approach, right? See here, we have done here. What we have done, this is the required number for us. Now, as of now, we want this number. We want 0, and lastly we have 8th bit to least significant bit as 1, right? So what is the operation we have done here? We just done 1 left shift I, then minus 1. That's all, right? So I can say 1 left shift by I. First of all, 1 left shift by I, then minus 1, so that I can get this value. Now do a AND operation with A. Fine. This is the formula I have derived. Let us check. First of all, I is 4. Sorry, I is 3, right? So I is 3 means 1 0 0 0. This is the value for this expression, right? Minus 1, which is 0 1 1 1. So this is the value. Now A, what is the value of A? 1 1 1 0 1 1 0 0 0 1 1 1. Now doing AND operation with this 1 1 0 0 0 0. I have got the result. So these are the steps involved in here. So let us see the code. This is the code for it. Let's see here. A and 1 left shift upon I minus 1. That's all, right? Just if you don't understand this, again watch this video once again. You will definitely understand. Okay, see that step by step procedure. Now let's go to the next example.